Hi everyone, so in today's video we're going to learn a thing or two about voltaic cell. Now if you haven't already watched my previous video about standard electropotential, go ahead and check it out just in case you're a bit confused or a bit lost about what we're going to learn today. Now voltaic cell, other words for it are electrochemical cell, chemical cell, or galvanic cell. But all these names are not that important, just remember about voltaic cell. So what is the function? The function of a voltaic cell is to produce electricity. The energy change would be from a chemical energy to an electrical energy. Now how do we construct a voltaic cell? We have to combine two half cells together. If you combine one half cell and another half cell, it will create a voltaic cell basically. Let's say a zinc half cell over here, then you combine it with a copper half cell here, and you attach it with a salt bridge. That's like a voltaic cell. Okay, but a voltaic cell is divided into two. We have a simple cell or a Daniell cell. A simple cell, we have only one solution, or if you want to memorize it, S for single, D for double. See, whereas Daniell cell, it has two solutions. Now what do I mean by one solution, two solution? So if we take a look at this is called two solutions because they have two different kind of metal ion solution over here that they're using. One is zinc ion and one more is copper 2 ion. So a simple cell looks like this. They're only using one type of solution, whereas this one, it's using two. So we have zinc sulfate and we have copper sulfate. We also learn how a salt bridge is used to allow ion to pass through to complete the circuit of the whole entire thing. But now we're going to learn a thing called porous porous. Now it has the same function as a salt bridge. It allows ion to pass through to complete the circuit despite it having different kind of metal ion solution. And in the previous chapter we learned a thing or two about E-naught, right? This symbol over here. But in this chapter, where we deal with two half cells, the symbol is E-naught cell. You have to write E-naught cell. This one's E-naught, this one's E-naught cell. So what are the strategy or sort of guidance to solve voltaic cell punya questions? So number one is to make sure you have two half equations with the E-naught values. Half, there you go. Okay, number two, draw a diagram for a voltaic cell, and this is sort of optional unless soalan tells you to do it, but it really helps you to understand it properly and visualize it. Is label terminal using the E-naught value. So remember, if it's more positive, then that's a positive terminal. The value of the E-naught value is smaller, then that one is a negative terminal. Okay, so in exam, we use the term anode and cathode. Now anode in voltaic cell is the negative part, is the negative terminal, and it's the part where it's losing electron, whereas the cathode is a positive terminal, which is receiving electron. And on a common sense perspective, so if it's negative terminal, it is tak boleh attract electrons, sebab electron pun negative, right? So negative and negative dia akan repel towards one another, so it's losing electron. Whereas positive terminal dia akan attract the electron, so it's receiving an electron. Okay, number four, you have to decide the direction of half equation concept. Decide direction of half equation, and the concept here is by using the number line method. So if it's more positive, the E-naught value, it prefers to go right, whereas if it's a negative E-naught value, it prefers going left. And you'll see what I mean later on as we go. Is rewrite half equation in one direction after doing this, and then combine two half equations to eventually form your ionic equation. Number 7 is to write your cell annotation, and for cell annotation, it's always there's always this two line here, and the rest is just one line. And before this two line here, over this side is the donating side, and over this side is the right side is the receiving side. For donating, after donating, this is the anode, this is the cathode, because it's donating and receiving. Kan donate kan je repel to kan the electrons, so it's the anode. And cathode, because it's a positive terminal, to receive electron kan, so receiving N over here. What else do we need to take note of? Cell notation, you must state the symbol. So aluminium, if it's solid, you kena buat bracket solid, S ke situ. Kalau aqueous, kena bracket AQ. But then since it's an aqueous kan, you have to specify your concentration. Okay, whereas solid tak perlu, just S. Kalau liquid, just put L. Okay, next, calculate the E-naught cell. The formula is E-naught from cathode, you minus E-naught from anode. So remember, like CAT, so cathode first, so C for cathode, then A for anode. Okay, example number 1, the two half equations. the information about the half cells over here. So we have half cell for zinc, half cell for copper ni. This is the E-naught value for each half cell. Now remember, we have to we can draw the diagram if you want to, or if you don't want, then that's fine. But you know what, it's probably best if you do it. Remember, one of the first steps is to decide direction. Once you already have your half equation, you decide the direction first. Yang ni dia lebih negatif daripada ni, so yang ni towards the left, yang ni towards the right. So we can write it that way. Zinc, nampak tak kalau left? Okay, then baru Zn2 plus 2 electron. Kalau tak, we tulis macam ni kan? But now no, because we know it's negative, so it's going to the left. It breaks down into this. So from here dia donate. Dan yang ni dia lebih positif kan? So lebih positif, dia gain. And betul lah, it makes sense anyway. Sebab kalau dia more positif, dia kan gain electron kan? Okay, so it's like that. And then you're going to balance out. You're going to make sure the electron sama. Because it's the same here, dua half equation ada dua electron, so just cancel and combine it. Zinc plus copper 2 plus equals to this 2. I cancel out. So from there you already form your ionic equation. Now let's write our cell notation. What happens is, this is the donating end, this is the receiving end. So before they donate electron away, dia zinc atom. But now bila dia dah donate electron, dia jadi zinc ion. Next is copper. Copper 2 plus ion, copper 2 ion. Bila dia receive electron, dia gain electron, dia akan form copper as a solid. See, so aqueous ni I have specified the concentration as well. Then you need to kira your E-naught cell value. So E-naught cell value is E-naught cathode minus E-naught anode. So once you've done it, you get your answer. This indicates voltage value lah of the E-naught cell. And some observation is from the zinc atom ni, because dia dah donate electron dia start to dissolve. Okay, so the zinc electron ni dia akan dissolve, whereas the copper 2 plus ni, dia daripada the solution, what happens is dia akan jadi, it turns into solid copper. So brown solid is deposited on copper electron, or you can say copper electrode gets thicker as well. Okay, next, because it's copper 2 plus kan, so the solution will be blue color. But because it has turned into a metal ni kan, so because brown solid is deposited due to the copper 2, now the blue color of the solution becomes colorless. Ta-da! We'll view other contoh soalan as well, so that it's like less confusing. Example number 2 that we're going to check out is this. We have cells here, which is the silver, and the chlorine over here. Now chlorine, if you look closely, it's in gas. Okay, so it's different. So this is how the diagram is going to look like. And if you notice, dia tak guna chloride punya, tak guna chlorine punya electrode, dia guna platinum punya electrode. And chloride ion tu is in the solution itself. So how do we solve this equation? Sama je. How do we solve this soalan? Sama je macam tadi. First, tengok your half equation ni. Which one's more negative, which one's more positive? Since we know this one's more positive, 1.36, we know that this one's going to the right and this one's going to the left. So kita tulis balik. Since yang ni going to the right, buat macam biasa, and you going to the left, tulis. Tapi remember, we have to form our ionic equation, and to do that, we will have to make sure our electron sama. So we have to balance it out. So to make sure electron sama, this whole thing kena times 2, so that we have 2 electron here. But when we times 2, yang ni pun 2, yang ni pun 2. So bila dah 2, dah boleh tulis. So we can cancel our electron now. Tengok, before the arrow ada these 2. So you're going to write this 2 inside your ionic equation. Then after the arrow, ada this 2. Write it there as well. So that's your ionic equation. Usually, basically when you have a metal half cell, you're going to use a metal electrode. But now, we don't have, chlorine is not a metal, right? So because it's a non-metal, we use platinum electrode. We don't use the metal electrode that's the same as the metal tu. Kalau kita guna zinc metal, then the electrode kenalah zinc juga kan? No, it's non-metal, so it's not a metal half cell. So we're gonna use a platinum electrode. Why the standard hydrogen electrode pun, if you notice, bila dia masukkan the hydrogen gas tu, kat bawah ni pun dia guna platinum je. So same thing, cell notation. So you have your donating and your receiving end. So donating end, mana yang donate? Dia donate, the electron must be further away from the arrow ni. You need to donate electron. So before donating, it's normal silver solid. After donating, it turns into silver ion. And remember, if it's in an aqueous kan, macam ni, aqueous, so you have to specify your concentration. And then baru you buat 2 lines here. Ini 1 line, ini 2 line. And then your receiving end pula, for receiving chlorine gas, but after receiving electrons, dia tukar jadi chloride. And because it's an aqueous as well, you have to specify your concentration. But remember, usually kan, if you notice, before this is soalan, the solid will be at the end. The 2 ends here will be solid. Macam ni, 2 ends here will be solid. But now it's not solid, right? It's aqueous. So we're gonna add the platinum. Solid kat sini. The electrode of each. Now you have to find out your E-naught cell value. Remember, is the E-naught cathode minus E-naught for anode. Cathode, so cathode is a positive side. So mana positive side is the larger, the one with the higher value. And lower value is this one. So, tolak je lah. Dan dapat jawapan. So this is the value of your voltage. Then observation, kita tengok sini. Before dia donate, dia normal solid, dia normal atom, normal metal. But after dia donate, dia dissolve. So the silver electrode has dissolved. Whereas, now, before this, the chlorine gas ada, and it's a greenish yellow gas, but now dia disappear sebab dia tukar jadi chloride ni. That is it. Okay, let's check out one more soalan, and that's about it for voltaic cell. But I do want to touch on this. So because this one is more positive, the positive value is higher than this one. So this is the positive terminal. So if you guys nak drop one, that'll be way better. You're going to write the positive and negative punya indication near the electrode itself. So any positive, tulis positive. Any negative, tulis negative. Last example to check out. So here we have your 2 half cells is going on here. So dia dah bagi you the E-naught value semua. Okay, great. So now we have to figure out dia guna which direction is it going kan. So tengok, based on number line, which one is higher. So between this and this one's higher. So this one's going to the right, this one's going to the left. Going to the right, so ini biasa Al goes to Al solid. Yang ni pula dia going to the left, so magnesium, then arrow, the Mg2+, then plus 2 electron. Tapi bila kita nak combine jadi ionic equation, we must make sure dia punya electron sama kan, the value of electron kena sama. So kena darab lah. And bila darab becomes like this. Cancel. Tengok before arrow ada siapa? This 2. After arrow, this 2. Boleh buat ionic equation based on this. So the ionic equation would look like this. 3Mg plus 2Al3 plus arrow 3Mg2 plus Al. The ionic equation. Now cell notation macam mana pula? So we have your donating and you have your receiving. So yang mana tengah donate sekarang ni? Yang ni kan. So before donate, dia solid, magnesium ni. Nampak tak, ada electrode, is solid. Then after that, dia jadi aqueous. So kena specify the concentration. You can write it as 1m or 1 mole per dm3. Now, yang ni, so before donate, then put a line. Nah, ni after donate. Okay, now put double line. Before receiving, after receiving. So before receiving, dia jadi aluminium 3 plus ion ni. Tapi after receiving electron, dia jadi aluminium solid. Remember, kalau aqueous, specify your molarity, your concentration. Okay, so apa observation kita boleh nampak? First, kita dapat tahu magnesium electron ni dia dissolve. What else? Yang ni, before dia receive, dia macam ni. Tapi after receive, dia macam ni. So we tahu a grey solid, because it's a metal kan, a grey solid is deposited. Or you can also say the aluminium electrode gets thicker. Ta-da! Now, calculate the E-naught cell value. Remember, ambil yang E-naught from cathode. Cathode kan more positive kan? So more positive yang ni. So ambil negative 1.66 minus E-naught from cathode. Cathode yang ni. So minus 2.38. Dapat jawapan that is it for Voltaic cell. Do comment down below if you have any questions or reach out to me on my Instagram. So that's about it. Bye.